Hi, everybody. After looking around today, I just noticed that maybe we should just go over a slight video about unit cancellation. So I put this together for you, and I hope that's going to help. I will probably do more like this in the future. Just make sure that you're looking through my announcements to find out what is due and when my videos will be coming out. So this one we consider unit cancellation, other times known as dimensional analysis, and I've even heard these called train tracks in the past. So what we're going to do today here is just look at some different unit conversions. Now this is one we're probably all familiar with. It's the 1 foot is equal to 12 inches. It does not matter if you put 1 foot over 12 inches or 12 inches over 1 foot. We're going to manipulate those for our purposes depending on what the problem is asking for. So for this one, it's asking for, it was giving us 3 feet and it wants us to get to inches. So we start with what our known is, what they gave to us, which was 3 feet. So we're going to use the conversion factor right here, which is the 12 inches is equal to 1 foot, because we want the foot to be on the bottom so that these guys will cancel out. Foot on the top, foot on the bottom, which means we're going to use this one right here. It makes sense for us to use this one and not this one. Okay, so once we get our inches up on the top, which is what we're looking for, and we do the multiplication because the 3 and the 12 are both in the numerator, we notice that we get 36 inches. Here's another one. Let's see how many centimeters are in 1.32 meters. Again, this is what they gave to us, 1.32, so this is what we start with. So we're going to start over here with our 1.32 meters. Now we have to ask ourselves how many centimeters are in a meter. We know that the centimeters are the smaller unit, and we know that centa stands for 100. So therefore there must be 100 centimeters in every meter. So we could use 1 meter per every 100 centimeters, or we could use 100 centimeters per every meter. We're going to use this one because we want our meters to cancel at the bottom. Okay, so if we put our 1.32 meters and we have 1 meter down here below, notice how these meters will cancel in numerator and denominator, and we're going to be left with centimeters up on the top. So now we just multiply. Since the 1.32 is in the numerator, we multiply that times 100. We can simply move the decimal place over 2 units if we didn't have a calculator with us, and we get 132 centimeters as our final answer. Let's look at a different one. Now we have 8.72 centimeters. That's what's given to us. That's what our known is, okay? And we want to know meters. So we're going to use this conversion factor again. 1 meter has 100 centimeters. And we could either pick between this one or this one. Well, since we're starting with centimeters, we're starting here with centimeters, we want to make sure our centimeters is at the bottom this time. So we want to use this one right here. Okay, we want to use 1 meter over 100 centimeters. So if we use that, we're going to notice that the centimeters cancel from top to bottom. And now we can just move over the decimal place 2 this way since we're dividing, and we end up getting 0.0872 meters for our final answer. All units must cancel. These centimeters cancel, and we're left with meters, which is what we wanted to begin with. How many meters? Check. Okay, we have our meters as a final answer. Let's look at this one here. How many feet is 39.37 inches? Now this time we're given 4 significant figures, and so we want to make sure that we have 4 significant figures in our final answer, which this one I'm noticing it does not, so we're going to have to make sure that that happens. Okay, so we have 39.37 inches, and again, we could either use 1 foot to every 12 inches, or we can use 12 inches to every foot. Since we're starting with inches, we want the 12 inches down here in the denominator. So now these two are going to cancel, and we have a division problem, 39.37 divided by 12, and we'll just say that there's one more unit there. I'm not really sure what it is, but we need 4 significant figures total here since this one gave us 4 significant figures. Okay, I noticed that error, so I wanted to point that out. Okay, let's look at another one here. How many kilometers is 15,000 decimeters? Okay, well, we're given 15,000 decimeters this time. And sometimes it's easier to go to the main unit conversion, which is meters, before we go either up or down from there. So I know that there are 10 decimeters in every meter. So we want to use 10 decimeters at the bottom so that these decimeters are going to cancel. And then we're just going to make one more step out of this. I also know that there are 1,000 meters in every kilometer. So we're going to cross out our meters. And then notice how we're left with kilometers. So now we simply multiply 15,000 times 1 times 1. And then we divide it and hit the equal sign. And then divide it by 10 and then divide it by 1,000. You should come up with 1.5 kilometers. Make sure you actually put this into your calculator. A lot of times students get the wrong answer only because of calculator errors. Again, you do 15,000 and then you divide it by 10 and then you divide it again by 1,000. Okay, let's check out another one here. Let's move this down a bit. Okay, this time we're going to measure the dimensions of a rectangle. So if we're doing length times width, we know that we are just dealing with the surface area. So if we do this one, we'll simply multiply the two, but make sure that you understand that you're also multiplying these centimeters twice. So not only are you multiplying these two numbers, but you're also multiplying these. So just make sure you're understanding that. Okay, so that's why you're going to have centimeters squared for your answer down here. So you just simply multiply these two and you have centimeters squared. Okay, this time now it wants us to convert 41.2 centimeters squares to meters squared. I'm going to show you a common problem that a lot of students do. They will take the 41.2 centimeters squared, okay, and they'll put it over 1 meter per 100 centimeters. Well, look what happened. I only got rid of 1 centimeter. We still have one of these left. So this is the wrong answer, okay? You have to make sure you do this one more time. So now let's start. Sometimes it's easier to say 41.2 centimeters times centimeters so that you know what that really is. And that way it clues you in over here to do this step 2 times. So we're going to take 1 meter per every centimeters. That gets rid of one of these centimeters. And we're going to do it again. Okay, so we have 1 meter divided by 100 centimeters. And look, it's going to get rid of the second one. Now, remember, we're also multiplying these meters together. So that's going to give us meters squared, which is what we want, remember? And we want these meters squared. So this is going to work out pretty well. So now we just simply take the 41.2 and then multiply by 1, multiply 1 by 1, hit the equal sign, divide by 100, divided by 100. You could also move this over 4 places if you wanted to. 1, 2, 3, 4. This is going to be your final answer right here, 0.00412 meters squared. 3 significant figures because we were given 3 significant figures. Okay, that's just a common one I like to bring up because sometimes I see students get that a little bit confused. Here's another one just to kind of hit home a little bit with this. So now we have 41.2 centimeters squared, and we got it to the millimeter squared. Okay, so now we're going to do, remember, do your centimeters times your centimeters so it's easier for you to see this along the way. And now we have to know millimeters is the smallest of the two. So we know it's going to take 10 little millimeters to equal 1 centimeter. Think of those little tiny dots on the ruler stick. So it's going to take 10 of these. So we take 10 millimeters over 1 centimeter. That gets rid of one of those. That clues us in that we got to do it again. So now we do it one more time. 10 millimeters over 1 centimeter. It's going to cancel out that second one. And you're going to be multiplying these two together at the end. And you're going to multiply the 10 times 10. So you end up getting 100 of the millimeters squared. And then you're going to multiply that by the 41.2. Okay? And so you're going to come up with an answer of 4,120 millimeters squared. Okay, same thing occurs with cubed volumes. So this time we're taking length times width times height. But remember, when we were doing our density problems, we came across a few of these. We're also multiplying the centimeter times centimeter times centimeter. If you recall from density, centimeter cubed is the same thing as a milliliter, okay? So this is just another way of getting volume. So remember your formula for volume, and now we just simply multiply. We ended up they gave us the length, they gave us the width, they gave us the height, so you multiply those three values together. But the biggie here is making sure they're also multiplying these units together. So whenever we put them all together here, we end up with 480 centimeters cubed. Now this is fine, this answer, because this is only showing two significant figures. The 0 is not significant, but that's fine because we were only given 2 right here and we were only given 2 right here. So therefore our final answer can only have 2 significant figures. Okay. So let's try to convert to meters cubed. This is sort of the same idea that we saw before, but this time we want to write out centimeters 3 times up here. Centimeters times centimeters times centimeters. That'll help us, okay? So first we have to think, well, how many centimeters are in a meter? We know there is 100 from the prefix centa, century, 100. So we have to take 100 centimeters for every meter. Now that's going to get rid of one of these, okay? We still have 2 left, so we have to do this 2 more times. So 1 meter over 100 centimeters again gets rid of that second one. And 1 meter over 100 centimeters again will get rid of that third one. Okay, so all of these centimeters are going to cancel out, which is what we want. And we're left with these meters up above. Now remember, we're multiplying these meters, so that's where we get the meters cubed. Let's switch this over a bit here. So this is just to kind of clean this all up here a bit. We could put 480 centimeters cubed over 1 meter per 100 centimeters cubed. And we could put a cubed up here to do that for all of this. This step here takes place all this stuff up here. This is just a shorthand version right here, okay? So some of you might like that shorthand better. All right, move this down here a bit. It's getting a little off task. So whenever we put this all together, we take this 480, we divide it by 100, we divide it by 100, we divide it by 100, and we end up getting this value right here. Okay? So these aren't too bad once you get used to them. Okay, this is just kind of summing things up here a little bit. Once again, if you take this centimeter and it wants it in meters, the first thing we would want to do is we can transfer the centimeters over to meters. Well, we know that we would have to move the decimal places over 2 spots. So if it's sitting right here and we need to move to the left 1, 2, we would get 0.152 meters. That's the first thing you need to do, is just, you can convert all these to the meters. Once you convert it to meters, now you can just simply multiply these 3 together. Remember, you're also multiplying these meters together, and you're going to get your final answer in meters cubed. Okay, here's our last one. We're going to convert to millimeters cubed. And as just a sum up here, we know that millimeters and centimeters are up by a value of 10. There's 10 millimeters to every centimeter. And by what factor do millimeters squared and centimeters squared differ? Well, now you take 10 times 10, so it's going to be 100. Okay? Same thing with this one right here. By what factor do millimeters cubed and centimeters cubed differ? Well, now you're taking 10 times 10 times 10, and you end up with 1,000. Okay? So hopefully this helps clear up any confusion when it comes to unit conversions. If you need extra help, I'm going to start recitation sessions every Thursday after school in room D120. So just stop on by around 4:30, 4:35. Please email me ahead of time to let me know that you're going to be there so I can come down from my room upstairs and we can go over whatever concepts that you need collectively as a group of students that would like additional tutoring. So I hope this helps out, and remember that this is due, since I want to do this video, I'm not going to make this due tonight for the end day. Let's try to get those in by tomorrow night, even though you don't have me tomorrow. And then my L day, please make sure that you're looking over this video either by way of class time or tomorrow evening, and this will be due for you on Thursday evening. So I will talk to you guys later, and I hope you enjoyed our first vlogcast here. Bye.